Welcome everybody to our session 2 for the year, our first large group session. Hopefully everyone was able to join their first, or most of you were able to join your first small group sessions last week. I actually missed last week, so I'm excited for next week to get to know my red group team members. But here we are today to share with you a lesson on architecture, design, and planning. And my name is Dina. I am an architect with Gensler. You'll hear that probably again in the video in a little bit. And I'm here with colleagues from Gensler and Parc Design Lab to share the architecture lesson with you today. Before we get started with the video, though, we have a few things logistics-wise we want to go over. So I'm going to share this screen here. And Cody, does that look right on your end, the full screen?
Yep, looks perfect.
Thanks. All right. So important updates. Please, 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 if you have not already, please complete your parent consent forms. Your lead mentors should have emailed instructions out to you. If you have any questions about parent consent forms, please contact your lead mentor. I've listed down here in the slideshow the mentor, the lead contact for each color group. So feel free to, snip this or take a snapshot of it or put it in the chat box if you need to write that down. We can copy those over, in fact. And then if you're having any trouble accessing your Google Classroom or, issues with joining these meetings, please also, again, reach out to your lead mentor. All right, so Cody is going to give us a quick schedule update.
Yeah, so students, we had to change a couple things around, as you see here on the schedule. Just one thing before I get into these date changes that are updated on the website. If you have already filled out the field trip or construction site tour form and it had the wrong date on it, that's fine. It's going to be moved to the 4th, so as long as we have that form, it is completely fine that it doesn't have that exact new date on it. So just to let everybody know that. However, the construction site tour has been moved to November 4th, and a backup day is going to be November 18th. A portion of the tour is going to be outside. It's at the NC Museum of Art, and a portion of it will be the bridge component, and the other portion of that is going to be the actual kiosk that's there. So we've got these two dates, and one of the major reasons why we changed it, the general contractor right now is in the process of a really critical stage of construction, and with bringing a large group through at this time is just not safe for us to do so. So we're going to move that back into November so that we keep all of you safe. So just keep that in mind. This week, we're going to, session 3 is going to be a small group feedback session. So that'll be next week, and it'll go back to a small group. So I know some of the groups had issues, including mine, with getting on to the Google Meet for the small group. We have made all those changes. And if you have any issues, just let us know next week. October 7th, that is going to be a session now for structural engineering. So we're moving the October 7th construction site tour back to November, and the structural engineering is going to move up to October 7th. And that's when we're going to start working on the bridge component of the project. And then October 14th, we've moved that up as well. College prep, we're going to be bringing in to the virtual session of a large group, ECU's construction office, and also NC State's design, architecture, and engineering programs. And they're going to come in and talk to you guys about their programs and some of the entrance requirements, depending on each of the different careers that you might pursue.
Great. Thanks, Cody. All right, so now today then we are going to, I'm going to switch it over to YouTube here and share with you about a 20-minute lesson on introducing you all to the world of architecture. So give me a second here while I make that happen.
Lucas, Dina had a question. Could you go back to the emails for team leaders?
Ah.
They're
Yeah.
also posted on the website, as Bill says.
Yes, but I could really quickly, while you're saying that, let's see if this will work. I could cancel and put this in the chat, but it might be a little messed up. No, it worked okay. There we go. All right. Mentors are listed in the chat. All right, so switching over to our video, and hopefully everything will go well with the audio. So let me know if you are all seeing YouTube.
Yep, looks good.
And I'm going to go to the full screen mode, confirm you see that. Does it look full screen?
Looks good.
Okay, thank you. All right, cool. I can't see it on my end.
No,
All right,
you always got to make sure the sound works.
Yep, and away we go. Hello, everyone. My name is Dina Wangberg. I am an architect with Gensler, and I'm here with my colleagues from Gensler and Parc Design Lab today to share with you all some insights on the field of architecture. So what is architecture? Well, at its core, architecture is both the process and the product of planning, designing, and constructing buildings and other structures. Something that really drew me in to architecture as a career was the combination of art and science. Architecture involves design and composition and color and materials, but also physics and geometry and technology. Historically, architecture evolved over the millennia as a form of expression of a civilization's culture, values, beliefs, power structure, as you can see here through many examples of religious structures, civic buildings, city gates, walls, fences, and other monuments. That expression of culture and civilization has continued even into contemporary architecture, now seen in things like skyscrapers, museums, monuments, housing. And over the millennia, the field of architecture has also greatly expanded. So something to think about is that those who are interested in architecture may find themselves drawn to similar careers in such things as landscape architecture or furniture and product design, where you might look at the everyday devices that people use in their homes. Or you may be drawn to brand design or graphic design, or perhaps naval architecture or interior design down to the smaller details of an interior project. And in the design of buildings, architecture includes a broad range of what we call typologies or building types. So today, architects have opportunity to design and study and influence things on the scale of a sports arena, all the way down to a single family home. So now I'll turn it over to Kevin.
Hi, everybody. My name is Kevin Tracy. I'm an architect with Gensler, and I'm going to talk about what architects do. So architects, at a very basic level, we help design the world around us. We have to be versed in many different subjects and skills, and we get to work on projects of all types and sizes. Now, some of those projects can range from very small pavilions to the very large towers. One of the things I like about architecture is that we get to work on all different types of buildings, different styles. We can be working on cities, stadiums, campuses, interior or exterior, and locations all over the world. So every day presents us with something new. And in terms of roles, there are many different roles when working on any of these projects. On a larger project, some of these roles might go to individual people. You'll have a designer, a code expert, an urban designer, an urban planner, an engineer, which we call a project architect, who helps put everything together, the manager running the business side of things, and then sustainability experts. So on any given project, we can have many different roles for people, or on a very small project, it could be one architect doing all of these roles for the project themselves. So an architect really has to know a lot of different subjects, and we're constantly learning about all different manner of things that affect the built environment. So one of the things that I like about architecture is getting to draw and getting to create things. And the way we do that throughout the process is through hand drawing. We do a lot of computer modeling. We do coordination, so we work quite a bit with other people. And then when the project finally gets into construction, we're making site visits and working with the contractor partners to make sure that everything that we've designed gets built smoothly. So it's a constant process of learning and communicating ideas and just meeting with different partners along the way. And within Gensler Raleigh, being that we live in such a growing and dynamic area, we've been fortunate to work on a number of different projects, sizes and scales, from office buildings to interiors to retail shops and plazas. So it's really, as an architect, you get to work on a number of different things, meet new people, go different places. So it's really a fun and interesting profession.
Hi, everybody. I'm Anna, and I'm an architect at Gensler. Now that you've been introduced to the field of architecture, we're going to take you through a project example that will give you a better idea of what architects do. The project we're going to share with you today is located in downtown Raleigh. The site is named for its block number within the city grid, dating all the way back to 1914. We've included a copy of that map here on the left-hand side of the slide and marked the location of the site with a blue star. In the aerial photo on the right, you can see the two buildings that now sit within the block and share a common courtyard in the middle. Today, we're going to zoom into the courtyard and show you the kiosk between the two buildings because it's a similar project type to the one you'll be working on this year. The image on the right is a rendering of the central courtyard. You can see the design of the retail kiosk in the lower left-hand corner of the image. Architects and designers use renderings to communicate ideas to their clients and to understand how a design will work when it was put into the context of its site. We collaborate with landscape architects to design the areas around the building, like paving, planter boxes, and benches. The site is just as important as the building itself, and you will have an opportunity to design your own site with your project. Buildings start with an idea and a purpose. A building's purpose is centered around how people will use it and how it's creating a better experience for its users. This is a retail kiosk, and it's intended to have a cafe-type program that can serve tenants from the two buildings along with the general public. Once we know a project's purpose, ideas start to form around how it should be situated and organized. The sketch on the left is an example of what we do during schematic design, a phase in the project when all ideas are on the table and the architects are working to arrive on the one idea that will push the project forward. Here's an example of some of the ideas we worked through when designing this kiosk. These are just 4 of the many that were presented to the client. We explored different shapes, layouts, and functions based on the program. During schematic design, it's important to push yourself on ideas and ask what if. It's the phase to really be creative and try new ideas, even if they may not work at first. On this page, you can see the different floor plans that correspond with the views we showed you before. You'll be creating floor plans like these for your project. We'll explain more about floor plans later, but we wanted to show you that these start on really early on in the process to understand scale and function of space. We work through floor plans to make sure the right spaces are next to one another so we can ensure the building will function well. After schematic design, we move into the next design phases where more and more detail is layered onto the initial idea until the full project is complete. Here are some photos of the final building. It evolved past all of those schematic ideas we showed you earlier. The central part of the cafe is enclosed program, and the two ends open up as the outdoor space where patrons can enjoy their coffee and food. It can also be used as an outdoor work area throughout the day for the building tenants. You can see how integrated it is with the site design and how careful attention was paid to the user experience. Next, we're going to take you through the construction document phase and show you what drawings architects create in order to realize a building like this.
Hello, everyone. My name is Theron Bronson, and I'm a project architect at Parc Design Lab. I'm from Kansas City, Missouri, graduated college from Kansas State University, and I've been practicing architecture for almost 10 years now. I'm going to elaborate on what Kevin discussed, what an architect does, by diving more into the case study Anna presented and show you some of the drawings created to communicate to the contractor. An architect not only has to design a building, he or she must create a set of instructions in order for that building to be built. Firstly, a set of construction documents contains two things. One, the actual drawing set, and two, a project manual with written instructions on how to construct the building and carry out the project. The drawing set or plans as seen on the left-hand side of the screen contain images that depict the actual building that's being built. Specifications that are part of the project manual as seen on the right contain written instructions on how to carry out the project and put those parts and pieces together. With construction drawings, the images are always to some scale, so that way they accurately depict the building or elements, and they can be measured from the actual drawing set if needed. You'll learn more about this later, but a common scale is 1/8 of an inch equals a foot. Basically what that means is every time the contractor measures 1/8 of an inch on the paper, it equals 1 foot in real life. Therefore, if the contractor measures 1 inch on paper, he or she knows that the element in real life will be 8 feet. The larger the fraction, the more zoomed in the drawing is. Again, you'll learn more about this later. In order for a contractor to be able to lay out a building, one of the first drawings he or she will need is an architectural site plan that shows where to place the building on the site. Usually a reference point to the property line or a marker on the site will be used in order to dimension the building to the actual site. You can see here that the reference point is at the intersection of these two property lines in red. The architectural site plan will show adjacent buildings, property lines, sidewalks, roads, while other site plans in the drawing set provided by other parties like the civil engineer will show utilities and other pertinent information to the project. The next set of drawings will be the floor plan as seen on the left and the reflected ceiling plan shown on the right. These two drawings are horizontal cuts through the building showing what it would look like if you sliced the building horizontally and looked either up or down. Think of it like a hamburger bun. The ceiling plans are called reflected ceiling plans because they are flipped in order to align with the floor plan to make them easier to read. If they weren't mirrored, the information would be on the opposite side. Again, imagine a hamburger bun and opening it up and how it would be flipped. These plans show the horizontal X and Y dimension relationship of columns, walls, doors, and they provide dimensions so that way the contractor can lay out the building accordingly. Sometimes references to heights are shown for ceilings and other elements if they're not called out elsewhere in the drawings. The next set of drawings provided are elevations on the left and sections as seen on the right. An elevation is an image of each side or face of the building, almost like you took a straight-on photograph. These drawings show the vertical relationships of elements in the Z direction, and they help the contractor in order to know the heights of different areas of the building. Sometimes elevations will show horizontal dimensions if there's something very specific that needs to be called out. Sections are also provided, which are vertical cuts to the building, almost like a sliced loaf of bread, that show the interior spaces of the building. Because buildings are complicated, zoomed in drawings called wall sections and details are needed to show the assemblies of the envelope of the building. The envelope, also sometimes called the skin, are the exterior materials that enclose the building. There are several layers and parts that all work together, hence why it's called an actual assembly. Here you can see a wall section to the left and a roof to wall detail, which is called a parapet. To touch on scale quickly, the wall section shown on the left is 1/2 of an inch equals a foot, where the detail on the right is 3 inches equals a foot. Lastly, architects will sometimes provide diagrammatic three-dimensional drawings called axonometrics. These images provide the contractor with a 3D depiction of the building or item to better understand it. Sometimes you see that there'll be just certain parts and pieces shown, and sometimes they'll show the actual whole building. Now I'm going to pass it off to Ryan to discuss precedents.
Thank you, Theron. My name is Ryan Kavanaugh, and I'm an architect with Gensler. Let's chat about the importance of precedents in the creative process. You've probably heard the phrase that something is unprecedented, meaning something has never happened before, or there's no historical context for something like that to have occurred. Context is very important when it comes to design. It's what allows designers to be creative and seek out incrementally new ideas or methods of building something. This means you can totally borrow a great idea or technique from a similar design, but what's important is that you make it uniquely your own. Check out the examples of churches on the screen. Keep in mind that architects and engineers looked for inspiration from what others had done before them, but in the end, these are all examples of a church nave spanning about 1,500 years. You can see the evolution from round arches to pointed arches to some pretty crazy arches on the right. The one on the right is the Sagrada Familia in Barcelona, and it's still under construction today. It's evident where inspiration was drawn from and how the design teams were able to learn from the past to draw inspiration for the future. So taking a look at your project, this more square burger example might be familiar to you since it's located right here in Raleigh. This is simply a small structure that could be fabricated off-site and anchored on-site with minimal construction. You can see between the top and the bottom left a difference in transparency, likely due to the function inside. So the restaurant at Square Burger wants you to see all the activities so you know that you're welcome to come inside and spend money. Whereas this other example on the bottom left likely has something much different, like an office or bathrooms or changing rooms or something they don't want just the general public to walk in and see. The two images in the middle are still on a trailer, so they feel much less permanent, but see how they fold open to create larger spaces during the day? You can see the top example is a partnership between Levi and Urban Outfitter focused on cycling. Sometimes on projects like these, it helps to think about a client and who that client might be, so you can start to choose design elements around what you think might work for that client and their brand. Lastly, you can see three examples of shipping containers on the far right. So what's interesting here is looking at how they look a lot larger than a shipping container. You can see how they expand into the exterior and make the space feel much larger. I know you're limited in size with the program, but you can get creative with what space is fabricated off-site and perhaps what's a furniture solution, something that you store inside and you can bring out during open hours to help make your space feel larger and more welcoming to the park. The next example is by Lab Architects in Hong Kong. It's inspired by local market stalls in China, which expand and engage with the public when they're open and return to their compact form when closed. So the gate over the retail counter opens into an awning during open hours. Each of these wood fins is a robotic arm that moves throughout the day subtly to mimic the water in the adjacent harbor. This particular kiosk also houses some infrastructure for the surrounding public space. Perhaps your kiosk could house a cistern, and you could use that to irrigate the landscape area around the kiosk. So when thinking about precedents, take a look online at sites like ArcDaily. You can learn a lot about projects on this website and easily search from thousands of projects around the world to help draw inspiration from. Dustin?
Hey everyone, my name is Dustin Brugman and I'm an architect at Gensler. We're going to look at a few bridge precedents and extract some specific takeaways from them. So at first glance, this is a utilitarian bridge that allows cars, cyclists, pedestrians to cross it safely. And you'll notice it doesn't really stand out in the crowd, but it does get the job done. Take a closer look at some of the detailing. There were a lot of simple design decisions with a lot of impact, like how the safety fencing appears to hover above the concrete, or even that difference in concrete curb between the pedestrians and the cyclists that makes the experience safer. You know, it really grows on you, and even like the care of how the bridge looks at night was carefully considered in this project. Next, this bridge by the same designers in Kansas City, Missouri, crosses over some busy railroad tracks, and it appears to reuse an old railroad truss. And note the juxtaposition or the mashup of all the different textures of glass, metal, concrete, you know, the glass of the elevator right here, and the stairs and the kind of pedestrian path is all clad in metal. the pedestrian has to go up vertically very quickly in order to get across safely. So that was kind of like the main concept in this. Lastly, perhaps you don't want your bridge to be in a straight line from A to B. Maybe you want to incorporate some more curvilinear lines, or even a mast-like structure that helps hold the bridge up, like you'd see in a sailboat. Once you've decided on form and kind of the route that you want to take, really think about those details of at the human scale, and how really simple, elegant design can really make that journey across more beautiful, like in this detail right here, which is a close-up of the railing right here. And we also just wanted to quickly introduce you and help you start to consider some sustainable strategies. And the earlier you do that, the better, because every decision you make will really affect a lot of potential you have for being off grid or self-sustaining. And that has to do with like how you orient your building to allow the most sunlight, and maybe solar panels, or how you're collecting rainwater, or just kind of really interacting with the environment around you. And so, in a future ACE session, we'll cover and elaborate on a number of those strategies and things you could do. And we'll introduce you to the lead, for example. But just wanted to quickly introduce you to a couple active and passive strategies, like I was just mentioning about the solar orientation, and really just being conscious and aware of what you can use in the environment to make your building or your bridge better for the environment and for for sustainability purposes. So we really want you to think big about your project first off, and we'll get into a number of these things. The engineers will love talking about all these fixtures and systems that you can use. There's plenty of things to go over, but think about those big picture ideas first, and we'll get to some of these really interesting things that we can integrate into our buildings later. And so in conclusion, we just want to thank you for listening and listening to us explain what architecture is, because we could have lectured for days if you really let us, and you're welcome for sparing you of that pain. We do hope this adds some context to the lessons we have for you coming up, and it really gives you some perspective and inspiration to get your project started. So thanks.
All right. Thanks, team. Hopefully everybody stayed with us through that session. And so now we thought we could spend, it's 5:30, so we can spend 5 to 10 minutes just answering any questions that you guys have about what you saw in the presentation. So feel free to type into the chat message bar, or you can unmute yourself, and we can fight over each other audio wise to to get in here. The question, I missed out on the first 10 minutes. What was in the video during that time? Well, I think to answer that, we're gonna say probably you should just watch the video link. But we kind of introduced what architects do and what is architecture at its kind of base. So I think I'd say that's the gist of it, but probably good to everyone will have access to the video after the meeting today. So yeah, and no problem. We know how it goes. Would any of my colleagues like to answer a question about, Bill asked the question, we mentioned urban planning, but we didn't really talk about that. Does anyone want to tackle that one briefly?
My brother-in-law is an urban planner, and he worked in DC, and his job was to, gain consensus. He was also in Annapolis, but his job was to gain consensus through the community as to what people wanted to see built, and try to plan the urban environment and direct projects into a way that would foster community use of buildings and get projects going that would really help people. Like in Cary, for instance, there's parks all over the place, and there's walkways that connect all those parks. So urban planners would say, hey, let's put this park over in East Raleigh, and let's connect it with a bridge that goes over the river, and let's make it go to the north part of town so people can ride their bikes around, and then they'll wind up in a downtown area and spend money. But so that's sort of what an urban planner does. That's what I understand an urban planner to do. I'm a contractor guy, so.
Thanks, Reed.
At LS3P, I do urban environments and master planning. So it's a lot of figuring out what the area has and what the community has and what they need, and really figuring out the gaps, and you fill in the gaps with what the community could thrive with. So you're really putting in perspective the environment, like the health and wellness of the people. You're kind of taking all the aspects and making a great place.
That's awesome.
It's like placemaking.
Thanks, Abigail.
They had a thing in downtown Apex last week, and the city planners had these boards up, and all the people walked downtown, and they had "What do you want?" on there, and people wrote on the board what they wanted. And I'm sure there was an urban planner that had something to do with that.
I think too, you can think about the different. We talked about the different branches of design, landscape architecture, urban planning, product design, brand and graphics design. They're all kind of different scales, but they all are based on like the same principles of design and composition. And maybe, they just work on different scales. We had, Ryan, were you going to say something?
Oh, I was just going to say, when I think of urban planning versus master planning, urban planning is more, I think, like everyone else said, you're talking about like the city level and what the community needs, whereas master planning might be more at like a development level. So you're talking about like, here's a parcel of land and what's a way that we could monetize that property. So like, are we going to build a hotel? Is it going to be hotel/office? Like what's the best use of that from a development standpoint, like someone to market the property for an architect to then design the building. So sometimes that property might end up being like 2 office buildings or an office building into a hotel, or is there retail? Is there going to be a courtyard? How are we kind of blending that space in the community? And that the types of uses that could be on that property would be something that's sort of defined by an urban planner in the city.
I wonder if either, I don't know, Theron or Dustin want to take the question about structural aspects of buildings. So somebody asked, do you want to take that?
Yeah, I'll take it. I saw that.
Yeah.
Hey guys, it's Theron. So we do deal with structural aspects of buildings a lot. What we do is we plan for them, and we work closely with the structural engineers in order to know how large and how big those elements are. So buildings most buildings are comprised of columns, beams, and slabs. And although we don't directly design those elements, we do plan for them. So basically, we'll go through and lay out the columns in a building because they affect a lot of the space in the floor plan. But an engineer, he or she will actually design how large that column is and how strong or weak the column needs to be. Kind of the same things for beams too. We don't necessarily lay out beams for buildings or floor slab thicknesses or any of that stuff, but we do work closely with the structural engineers because those elements affect the actual design of the floor plan and of the building as a whole. A lot of engineers, they'll kind of laugh at architects because we want things to be really thin and really tiny, and we really push them a lot because engineers, they're engineers. They have to engineer and they have to put a lot of onus on themselves to make sure things stand up, and so they want to make sure that things are strong enough. Well, usually when you do that, things get bigger and bulkier and they don't look as nice. And so architects really push engineers a lot to make things thinner.
I think too, you can think about, I think that was really great, Theron. And I think that, in school, architects, you learn in architecture school to you kind of learn a little bit about all the different topics that engage with architecture. So structural design and mechanical systems and electrical and plumbing, you kind of dabble in all of those, and you get like a really general, sense of the basic information that you are going to need to know. Ultimately, the architect does bear a lot of responsibility for, what we call life safety in a project. And over the years, as building codes and different professions have evolved, every consultant or every team member, the mechanical engineer, the architect, the structural engineer, each one of them is responsible for essentially, signing. They're legally responsible for their documentation, for their part of the project to say this thing is safe. So it's a lot of teamwork, but the architect kind of has to be like the generalist in all of it.
Well, and also in terms of schooling and licensure, I know when I was in school.
Oop, we can barely hear you. Whoever.
It sounds like Stu.
Can you hear me?
You sound very far away.
Okay, I'll fix it later.
Okay. Let's see, we got just maybe a few more minutes, couple more minutes before we need to jump over to introducing you to the activity. Sustainability and satisfying lead requirements going to be a portion of this project. I believe that typically what we've done in the past is we have introduced students to the lead checklist. It is not a requirement to fill out a checklist, I don't think, but it is something we encourage you to do as part of the process to understand the different sustainable design elements that are kind of out there, and that with LEED, for example, which you'll hear about more later, but with that, you can kind of understand like what you would get points for if you were designing a LEED project and what you might start to think about in your own project. But yes, you should have sustainability is a requirement of the project, that you've at least, that everyone has integrated some aspect of sustainable design into their project.
Can you guys hear me now?
Yeah.
Okay, so structural engineering, at least for architects, in school, you're probably going to have some sort of elective on concrete or wood for structural engineering. So in college, you'll be learning about structural engineering enough to be dangerous. And then at the next level, when you're taking your licensing exam for architecture, there is a structural section. So there you'll also have to be well-versed enough to pass that exam.
Thanks, Sue.
Yeah.
I love this question from Bob. Bob asked, what is the typical design life of a building? In other words, how many years can it be safely used? Anna or Dustin or Kevin, somebody on our group want to tackle that one?
Yeah, I can talk a little bit about it. I think it kind of depends on the building, right? We build our houses with the idea that it's going to last several generations. Institutional buildings like hospitals and university buildings, some of them have been around for 200 to 400 years, depending on where you're from. Whereas other retail buildings, they might have a usable life, unfortunately, of 20 to 40 years. I think as architects and sustainability-minded architects, we want to take into consideration the fact that most buildings, if not building materials, are going to be here long after we are. So we want to design them so that they are permanent and consider that, the life cycle of the building.
Yeah.
Hey, Bob, it's oftentimes the owner who sets that forward and how much money he's willing to spend. So if you are working for the state of North Carolina, their buildings, they want to last anywhere from 50 to 100 years. A developer who's probably going to turn this over in 7 to 10 years, get his money and get out, he's not quite as concerned. So even though as an architect or an engineer, you would like to make the life of the building as long as you can, it's a budgetary restraint oftentimes.
Yeah, thanks, Bill. And we didn't talk about like adaptive reuse or restoration, which might be another, it's not really, it maybe is not a separate field, but it's an associated, practice in architecture, that maybe you're not building a new building, but you're taking an existing building and you're renovating it, right? An example of that our office has been involved with recently is there was an outlet mall in Morrisville that had been abandoned and had closed down. And the design team took that project and essentially retrofit it to be office space. So that extends the life of a building that would have otherwise been, quite short in history.
Bob, what's the life of a bridge, man? You build a lot of bridges all over the world.
Well, it depends. They typically are designed for 50 years these days. Some bridges are older than 100 years. If you look at the Florida Keys, Flagler built a railroad bridge that still exists, and it was built under pretty tough circumstances. But like any structure, it depends on maintenance as well. How well do you maintain a building or a bridge? That is one of the factors that determines its life cycle.
Yeah, like for example, like the Golden Gate Bridge, when they repaint it every year, and once they finish on one side, they go back to the other side and start over again.
Yeah, it's that's right.
Let's see, there was, we probably need to move on to the activity. The last question then is Declan asking Bob, what's the most structurally secure truss bridge for center load? Do you know that off the top of your head, Bob? Putting you on the spot.
Say that again. You tried to put me on the spot, I think.
Yeah. Yep. What is the most structurally secure truss bridge for center loading?
Oh gosh, you look at typical truss bridges are very much used for railroad bridges, and some of them are 100 years old, but they're usually steel. Steel is very sensitive to maintenance. Like Sue said, it's continuous painting, and that's one of the problems these days, where you see some of these old truss bridges not very well maintained. They start to rust and they start to corrode, and then they become unsafe. So
yeah, a lot of these structural questions, they're probably going to be answered in the structural session that's coming up.
Yeah, but this is cool. This has been great. So we will now introduce you guys, and you can still feel free to put more questions in the chat box, but we're going to switch over now to our activity.
So once Dina is bringing that up, the activity should be posted on your Google Classroom as the second activity. I think you guys had the scale activity the previous week, so she's showing you the activity associated with the architecture.
That's right. So everyone, are you seeing the floor plan? I think you are. Yes?
Mm-hmm. Yes.
Okay. Sorry, I can't see you when I do this. So, okay, great. So just a quick, in case anyone's curious for the students' benefit, the program, so this is just a PDF file, which is what it is, accessible to all of you. If this program seems unfamiliar, this is a program called Bluebeam. And I'm not sure actually if Bluebeam is available to students for free.
There's a trial version that you can do for 30 days, but I haven't seen a student.
Okay. So a lot of architects and engineers use Bluebeam, but so this may not, all of this stuff around the activity may look different when you open it on your screen. But the floor plan activity has 2 pages here. And the intent of this is not to be like the be all end all of your kiosk floor plan, right? This is just This is to get you started. This is to get practice with using the scale, understanding architectural scale and drawing to scale. If you remember from the video, or if you came in, late after the video, Theron talked about the hamburger. So this is the analogy here. The floor plan is like taking your hamburger and removing the top bun and looking down at the hamburger, or kind of slicing through it and removing the top. Typically, a floor plan is taken around 4 feet, 3.5 to 5 feet above the floor. And you can see here that there's a first floor and there's a second floor laid out here. The floor plan activity scale is 1/4 inch equals 1 foot. So if you print this out at home on an 8.5 by 11 and don't scale it, print it 100%, then this line right here should measure 1 inch. So that's kind of a key if you want to print it out and try that at home. So you can, use what you learned from the scale activity to start to understand the dimensions of your trailer that you will be moving your kiosk to the site via. So there are instructions here at the bottom. Step 1 is to measure the overall, so for the activity at least, step 1 is to measure the overall dimensions, so the length of the trailer and the width of the trailer. And those little boxes are where you would write your answers in feet and inches. And then step 2 is to plan out, start to think about the spaces that you would want to have on now. And I'll say too, I don't think your kiosk is required to be 2 floors, but it can be 2 floors. We have a height limitation that we'll talk about more in next week's elevation activity. But we are using the infamous Peace Street Bridge as our limit of 12'4" as a total height, so that in case you need to, your truck driver needs to go down Peace Street, they will not get stuck. You can start to basically think about what you want to include in your kiosk. Step 3 is to use the plan elements on the next page. Anna's going to talk more about that. And then a reminder in step 4 here to make sure that you think about the entry. Where would you want people to enter? And Ryan showed some really cool examples of kind of modular units that folded out from the trailer. So, your entry can be something that kind of pops out from the trailer or kind of steps inside of the trailer, if that makes sense. So lots of, kind of endless ideas there. Also think about, start to think about where you place things related to what plumbing fixtures, sinks, any, cooking that you might need to do, as well as windows within the kiosk if you want any windows. So I'm going to let Anna talk about page 2. Anna, are you with us still?
I am. Sorry, I was double muted.
Yes.
Hey, everybody. So thanks for going over that, Dina. I think this is the fun part when you get to really start to think about, what your program of your project is going to be and how people are going to use this space. So we've given you a sheet here of components and kind of thought starters around what might be in the kiosk. So you don't have to feel limited to these by any means. You can, look up different sizes of things and create your own if you would like, but you're also encouraged to print this at 100% scale and cut these pieces out, and you can start moving them around on the on your floor plan and kind of getting a sense for how much space you're going to have and how things will start to lay out. So you can see some components we've dropped in here, like display cases or storage shelving for what you might need in your kiosk depending on its use, some tables and chairs, equipment over on the right, A lot of times you need a cash register if you're going to make money, and a computer. And so maybe you have a menu. So just thinking through a lot of those components, and these are just a way to get you started and give you some scale to the floor plan itself.
So going back to what Dina said about the height restriction with the bridge, was it 12 feet 4? Is that what you said?
That's what I Googled today to confirm.
Yeah, so to think about that, if it's 12 feet 4 inches, if you had like a really low ceiling, 8 feet, that doesn't leave you much for the second floor. It's probably 4 feet left. So what's probably going to end up happening for the second floor is more some sort of storage area or another area for mechanical room of some sort. So think about that when you develop your second floor area. It's probably not going to be occupiable, meaning people will be on it.
Unless it's a roof deck, right?
Oh yeah,
and you didn't have a roof on it, and you could have a place for people to occupy if you wanted to give them a view or a different vantage point. So something else to think about.
Because there is a limitation, right, to the trailer in terms of its width and length and height when it's on the road. But when it gets to the site, if you've got something there, as long as it's contained in the trailer, maybe you pop it up from the second floor, so it's an element that could pop up. So your height limitation is just to get it there.
Mm-hmm.
This is why we love being architects.
Yeah.
So that brings us to the conclusion. That's the activity. So everybody should, go get the activity from your classroom, print it out, start thinking about what you want, confirming what you want your kiosk to house, first of all. What kind of kiosk is it? What's your program? What do you want to sell or share or give away from that space? And then we would hope that everyone would, before next week's session, submit your activity through your Google Classroom. I think, are we doing them on drives? I missed last week. So are we doing them on like a drive folder, a Google Drive?
No, I think they're going to submit through
in the classroom.
Yeah.
Okay. Yep. So submit through the classroom and get some feedback. And then questions.
Yeah, you can, Jordan, I think what you mean is, can you do your own elements? Like if the elements that are on the sheet aren't what you like, you can certainly draw your own or find your own and place it on your floor plan.
And don't be afraid to like brainstorm with lists or, sketch out a floor plan freehand once or twice. The whole process of design and iteration, we never really get it right on the first try. And so just encourage you to think through it once or twice and instead of just copying and pasting, and really think about the space that you're creating while you're working on the activity.
That reminds me, sorry, Sue, but that reminds me, next week, what we didn't talk about in too much detail is next week in your small groups, it's a feedback session. And so I don't know if one of the lead mentors wants to talk more about this, but what I'll say because Dustin, you brought up a good point. You're welcome to bring, the idea from a feedback session is bring your ideas, bring whatever brainstorming you've done about your project. And if you have a list of things you want to include in your kiosk, but you don't have them on the plan yet, that's great. Let's talk about it. So that'll be an opportunity next week to talk through that in kind of small groups and breakouts.
That's a good follow-up to Noah's question. Does it have to be the final design? No, it does not.
It shouldn't be the final design.
Right. We don't expect you to design something in 1 week.
Unless you're a genius and then come work for us.
I don't want to speak for all your architects, but don't y'all have like sketchbooks that you doodle in all the time and you just kind of doodle ideas down and tweak them around and then turn the page and do another one? And you look at Picasso, he had millions of little sketches that he, never finished, but he got ideas and he drew them down. So if you can get a little notebook and a little sketch pad and just do your ideas.
Yep.
Yeah, the kiosk can be anything you like.
Anything
I think
that
you have
serves a
to consider
purpose.
the site, right?
Yeah.
You have to consider what the site is near. So you're going to have a bridge. You're going to have this lookout area where people are going to enjoy views. So maybe it's a binocular rental kiosk. And then if you're on the other side of the bridge near the performance area, there's people want to probably have tickets or food or, you know, like I think you said food stand. Yeah.
Gift shop.
Yep.
Birding material.
So there was a thing that we suggested last year with the 8.5 by 11. If you have one of those clear sheet protectors, you can put it over the piece of paper and then use a dry erase marker to kind of sketch and redraw and iterate on top of the drawing without having to print multiple sheets.
I would suggest start thinking about what your bridge is going to look like. In the presentation, you saw a number of very creative architectural bridges. Those are just examples, but you can use your imagination and come up with some interesting concepts.
I'm going to take a picture of a bridge in Gettysburg, Pennsylvania that my buddy's great-grandfather built in 1860, and it's still standing. So I'll share that with y'all. I'll give you an idea.
Awesome. Well, this has been so fun. You guys have all had really fantastic questions. And for those that weren't able to make it or had to join late, you'll have the video posted and can follow up, and feel free to reach out to your mentors through the classroom during the week as you start to work on your kiosk. Anything else? Sue, did I miss anything?
Students, I guess we're always going to stay afterwards if you have any more questions, but the students that know what they're going to do, go ahead and you can go ahead and leave.
Before I go, I wanted to ask Bob, what's your favorite type of bridge to design? Like a pedestrian or other types?
Well, for bridges, but if you look at the different types of bridges, suspension bridges are probably the most interesting types of design. They're very complicated in a way structurally. Once they're done, they're beautiful, but there's a lot to designing a suspension bridge and also to building them. So I think at the right time we'd be glad to talk a little bit about that, how these different types of bridges are built.
Well, thank you.
Sure.
Thank you for the presentation, everyone.
Thank you.
Yeah, good job, Gensler.
Oh, and Parc Design Lab.